So what happens here is to go for test for congruency. Now I'm going to draw two triangles at the start, okay? And the two triangles are the following, okay? So I'm going to just go for just a basic, just this triangle here, okay? There's one of them, and here's the other. These triangles are, one is an enlargement of the other. Do you know what I mean by enlargement? As in, it's bigger. The same angles, they're equiangular, but they're not congruent. To be congruent, you have to be exactly the same size. So they're only congruent when the sizes are exactly the same. So they're pretty similar now, okay? So what you're looking at to prove that two triangles are congruent is the following. There's something that's called SSS. It means side, side, side. If you prove that the sides of the triangles are the same length, they have to be the same triangle. Now I'll show you now an example of this, okay? An example would be if I have this one here, okay? This one here. I need two. They're roughly, they're meant to be exactly the same size, okay?
I mean, you only need to prove two sides.
No, you have to prove three for this particular proof. Okay, now guys, what you have here is this, okay? You can say the following. Alright, AB is 12, C, okay, and then we're going to have the point D, E, and F. Now here's how you go about doing this, okay? And you have to do it sort of formally. You have to write down the names of what length you're talking about. So here's how you go about doing this, okay? That one can be 8, which means this one here is 8. This one here is 12, and the other one should be 10, okay? Now guys, here's what you do. To prove that they're similar, okay, what you do is this. The line AB, or it's usually big letters these days, the line AB equals what line on the other triangle? EF, okay? Now, I always write down beside that, side, okay? Just S-I-D-E, side, okay? What about the next one? What's the next one that's equal? AC equals? DE, okay? And DE is side as well. And then finally, the last one is going to be BC. You can call it CB if you want. Equals DF or FD, whichever way you want to call it. Just do alphabetical order, I suppose. Keeps it easy. Now, what you do here, once this happens, is what's the name of the left triangle? What's the triangle to the left called? The triangle?
ABC.
ABC. On the right, triangle DEF. Now, finally lads, you do this. Therefore, triangle ABC and DEF are congruent. And that's if you're asked to formally explain why. You're given a reason for each one. Okay? It means they're exactly the same. Okay? Let's go to the second theorem, okay? Second theorem is two sides and the angle in between. So another example would be something like this, okay? I get a triangle. Okay? Once again, this type of triangle here, okay? So not that small. Okay? What I do is, you can see here guys, I'm cloning it, which means it's exactly the same. And now I'm just going to spin it around to make it look slightly different. Okay? So what we're doing here is this. Once again, we're going to label it. Going to label this one A, B, C. Now, this part here is going to be D, E, F. Okay? Now guys, what's happening here is this. If I say here is 8, okay, and this one here is 10, and then on the other one I'm going to say this is 10, this is 8. You haven't got enough for what's it called? You haven't got enough for SSS. Okay. Now, if I told you this here is like 110 degrees, and this one here is 110 degrees, what can you say about both triangles now? They are congruent. You gotta use the word congruent, okay? So what you're gonna do is this, guys. AC equals DE, okay? And then that's your side. You're gonna put the angle part in between. Now, what's the name of this angle here?
Angle ACB.
Angle ACB. Connor Duggan. Okay. The name of this angle here is angle ED. That's a F there, sorry, EDF, okay? Angle EDF, that's your another angle, and then finally your last side, BC equals DF. Now guys, that's grand. The one thing you really got to look out for, and this is where people get confused, okay, is you got to look out for this. It's the angle has to be between the two sides, you know. Angle side angle means that the angle you need to know has to be between the two sides. If I was to change this question, okay, I'm going to change this question slightly, okay, and here's what I'm going to do. If I was to change this question and I gave you this angle here as 30 degrees, and then I gave you the angle between the 10 and the non, that's 30 degrees as well. Is that enough information to prove it?
No.
No, because it's no longer between the... you need angle side angle. It has to be side angle side. So you need to have the angle that's in between the two sides, you know. So you can see on the other triangle, I know these two sides here, but I don't have enough information to prove it. Now guys, if I gave you one more angle, and I mean one more angle, okay, if I gave you this angle up here, do you now have enough information to complete it?
Yeah.
You don't, but with one step, you do. What's the step?
Add the angles
together and get this one as 100, and then you can do angle side angle like we did in the first question. Okay? Next one. Once again, we're going with there's only four of them. We're out now through 3 of the 4, and I can let you start your questions pretty soon. Okay? Here's one here. Okay, once again, gonna clone it and just spin it around to make it look different. That's all they do in your book. Okay? And then once I've done that, I'm gonna label them like I did last time. Now this time I'm not gonna use numbers. I'm gonna use signs to show that they're the same, okay? So I'll show you now. A, B, C, label it like last time. D, E, and F. Now what I'm gonna do this time is this. 1, 2, 3. 1, 2, 3. What does that mean? EF same as AC. One line through this one, and it'll be one line through this one. DE is the same length as AB, and finally BC, same length as DF. Now that's if I was giving you 3 sides. I'm not. So what I'm actually doing is angle side angle. Now what you got to remember about angle side angle, or ASA. For ASA, you need to have, and if I do this in green again, you need to have the 2 angles and the side that links them. So what I basically need is this angle here, the side that links them, and this angle here. Okay? So what I need to be told is this. I need to be told that this angle here is the same length as, it's the same size as this angle here. The same sign means they're the same angle. And then I can be told that this one here is the same one as this one here. Do I have enough information now to show that they are congruent?
Yes.
I do, because I have this angle, the side that comes in between it, and the other angle. So you have to, once again, you got to write it out formally.
The angles are the wrong way. A doesn't equal angle F.
Sorry? Angle A equals angle F.
No.
Oh, it's the opposite way around, is it? Yeah, sorry guys. Gavin's right. Yeah, that's the dot, and that one there is the, it still works out the same, sorry. Okay. Yeah, you're right. Sorry guys, Gavin made a call using his eyesight alone, and he's dead right, because at the angle, one was bigger than the other one. Sorry, excuse me. Now guys, here's how we do this. You write down, once you realise it's ASA, you write down ASA. Then, when you're done with ASA, here's what you do. You write down angle. What's this angle A, by the way, guys? What's angle A called? How do I name it? BAC. Angle BAC equals angle DEF. Kane, what sides are equal? Huh? Just yourself. Equals EF. Well done. And find the last angle. Last one. The last one. What's the last angle?
BCA.
BCA. Well done. Equals what?
DEF.
DFE. Okay, guys. DFE. Okay, guys. The triangles ABC and DEF are congruent. Okay, guys. Finally, going to alter this question a little, and here's how I'm going to alter it. I'm going to alter it by changing this angle here for this angle over here. I'm going to call this one X. Do I have enough information now to prove they're congruent? I still do, because I can still prove that this angle is the same as this one here. I'm one step away from proving that they're still the same. It's still the same question. Now, if I gave you no angle, if I gave you no third angle like this, do I have enough information to prove it now?
No.
One angle, one side, not good enough. Not enough to prove that they're exactly the same. Okay, next one. Finally, right angle triangles. Last one. Right angle triangles, to prove that they're the same, is like this. Okay, you have a right angle triangle, and you have it, to make it congruent, it has to be exactly the same size. So there's the second one. You spin the other one around to try and make it look slightly different. Now, what happens is, for right angle triangles, okay, I label this A, B, C, and then the other one D, E, F, the usual. Okay, D, E, and F. Now, I have to prove that these are the same. To prove that they're the same, you have to know there's a right angle, you have to know there's a hypotenuse, and you need one other side. So if I give you this, I have to give you that the hypotenuses are the same side. Would you agree with that? Now, sorry again. The hypotenuses are the same sides. Okay? This angle here is the same one as this one here, and you need one other side. So if I say AB is the same as DE, that's it. So you just got to do it formally. And to do it formally, you do it like this, okay? Angle ABC equals what angle, Kim? Gallagher? DEF. That's your R for a right angle triangle. Now your H is your hypotenuse. Okay? So what's the hypotenuse? AC equals? Anybody? AC equals? DF, the side that's opposite the right angle. Yeah. And finally, one other side, AB equals DE. AB equals DE, and there's your side. This makes RHS, right angle, hypotenuse, side. Now you know that both the triangle ABC and DEF, and you have to write down triangle in front of it, are congruent. Okay guys, so that's basically the gist of everything here.